Question 9.46. A particle is moving clockwise in a circle of radius 1 meter. At a certain instant, the magnitude of its acceleration is a equals 25.0 meter per second squared, and the acceleration vector has an angle of theta equals 50.0 degree with the position vector as shown in the figure. At this instant, find the speed v of this particle. So let us first write on what the question has given us. I have the radius of the circle, which is r equals 1 meter. Then we have the total acceleration a, which is 25.0 meter per second squared. Then we have the angle this acceleration vector makes with the radius vector or the position vector r. And we need to find with what speed v is the particle moving. Now the speed of the particle is related to the centripetal acceleration as ac equals v squared over r, where ac is the centripetal acceleration, v is the linear speed of the particle, and r is the radius of the circle. To find v, I can rearrange the term over here by multiplying with r on both sides and write v squared equals ac times r. Take square root on both sides and then we get v equals square root ac times r. So I can calculate the value of linear speed v if I know what is the centripetal acceleration of the particle. We have the total acceleration given to us in the question. And total acceleration is nothing but a resultant of tangential acceleration at, which goes along the tangent to the point, and centripetal acceleration ac. And this centripetal acceleration is nothing but the projection of total acceleration on the radial axis. So if I want to find centripetal acceleration in terms of the total acceleration, I can write AC to be equal to A cosine theta. And why cosine theta? Because if I were to complete this triangle by drawing a perpendicular, you would notice that AC, or the centripetal acceleration, is the side which is adjacent to the angle theta. And any side which is attached to the angle theta, we can relate that side with the cosine of the angle theta. Because we know cosine theta is equal to adjacent side over the hypotenuse. Adjacent side here is AC, hypotenuse is A, and I can calculate my centripetal acceleration AC by multiplying the total acceleration A with cosine of the angle theta. Now let's substitute this in our equation for V. I can write V equals square root. In place of AC, I will write A cosine theta times R. Now substitute magnitude of total acceleration is 25 times cosine of the angle 50 into the radius, which is 1. And when you solve this, you get the speed of the particle at that instant to be 4.01 meter per second.